For more than a century, geology has relied on a principle so fundamental that few ever question it: the law of superposition. It tells us something simple and powerful. In undisturbed sedimentary rock, the deeper layers are older than the ones above them. Layer by layer, Earth writes its history in stone. Entire disciplines depend on this order: paleontology, climate reconstruction, archaeology. It is the chronological spine of our planet's story. But in a remote and sparsely studied region, researchers documented a formation that does not follow this rule at all. Instead of orderly stacking, the layers appear inverted, compressed, arranged in a sequence that should not exist. The anomaly is not hidden. It is not theoretical. It is visible in exposed rock faces, measurable, verified. And that is what makes it unsettling. If Earth's history is written in layers, this formation reads the pages out of order. Under normal conditions,
it does not collapse the system overnight. It simply sits there, unresolved. Researchers proposed alternatives. Perhaps subtle tectonic compression left minimal traces. Perhaps rare environmental conditions accelerated deposition. Simulations were conducted, models adjusted. Each explanation solved part of the problem. None solved all of it. Compression models could explain inversion, but not the clean boundaries. Rapid deposition could explain overlap, but not isotopic reversal. With each added assumption, the explanation grew more complex, and complexity began to exceed necessity. At some point, the question shifted. Were the models incomplete, or was this formation merely inconvenient? As debate continued, momentum slowed. Publications referencing the formation became less frequent. New research proposals shifted elsewhere. The anomaly was not disproven. It was not reclassified as error. It simply faded from urgency. Funding favors clarity, reproducibility, application. An anomaly that resists integration presents risk. Without recurrence or broader context, it becomes difficult to prioritize. And so the formation entered a quieter phase of existence: documented, archived, unresolved. Scientific models are not absolute truths. They are frameworks built from accumulated observation. When data fits, confidence grows. When data does not fit, decisions must be made: modify the model or marginalize the anomaly. This formation appears to have entered the second category: acknowledged but compartmentalized. Not suppressed, not celebrated, simply isolated. The formation still exists. It is accessible, measurable, visible to anyone who studies it. The contradiction is not hidden. It is interpretive. Attempts to force coherence often require adding new assumptions not independently verified. Over time, models stretch to preserve continuity, but stretching has limits. The deeper question is not whether the experiment was flawed. It is how scientific systems respond to boundary violations. Models are constructed to explain observed reality. When reality exceeds the model, refinement becomes necessary. But refinement requires confidence that the deviation is not accidental. In this case, the anomaly occupied a narrow margin, too structured to ignore, too inconsistent to confirm universally. That narrow margin became its resting place. Similar stratigraphic irregularities have been noted elsewhere, often smaller, less clear. Most are explained through complex tectonic histories, but this formation combines inversion with structural stability. It invites comparison. When anomalies repeat across regions, even subtly, they suggest refinement may be necessary. Refinement depends on attention. Without attention, contradictions remain static. The laboratory where the experiment was first conducted still exists. The equipment has been recalibrated for other studies. The anomaly remains part of the record.
It did not collapse the theoretical framework. It did not rewrite the equations, but it introduced tension, a reminder that models describe reality. They do not define it. The experiment produced a result that should not have been possible. It was measured, repeated, documented, and then it settled into quiet uncertainty. The boundary was crossed once. The question is not whether it happened. The question is what it means when limits prove negotiable. Earth's history is presented as coherent, layer upon layer, predictable, ordered. Textbooks reinforce this image. Museums illustrate it.
This formation does not destroy that narrative. It complicates it. It suggests that chronological order may not always be as straightforward as depicted. The rock remains where it is, measured, recorded, unresolved. And the question lingers. If one timeline breaks, how many others remain unquestioned?